Good morning, students. In the last class, we discussed about the units and measurements, starting with the physical quantity. So, physical quantity is classified into two types. One is fundamental quantity, and another one is derived quantity. So, physical quantity is classified into two. One is fundamental quantity, and another one is derived quantity. So fundamental quantities, the quantities which are independent from other physical quantities, though that quantities are called as fundamental quantities, and derived quantities, the quantities which are defining by use of the fundamental quantities, then those quantities we are called as derived quantities. So example for the fundamental quantities are length, distance, width. So all these are the fundamental quantities: length and mass and time. So these are few examples for the fundamental quantities. Similarly, examples for the derived quantities are speed, acceleration, next force, work done, that is work, energy. So these are the few examples for the derived quantity. Here speed is derived by the using fundamental quantities, that is length and time. And also the acceleration we derived from length and time square. So force, mass and length by time square. So by using these fundamental quantities, we are defining the physical quantities. So these are all the physical quantities which are defined by using the or by the help of the fundamental quantities. Then those quantities we call as derived quantities. The units which are, that is the standard units which are going to measure the fundamental quantities, are called as fundamental units. In the last class we discussed about all these fundamental units, right? The quantity, the units which are going to define the fundamental units, that is measure the fundamental quantities, then those are called as fundamental units. And the units which are going to measure the derived quantity, then those are called as derived units, or the units which are going to define by the help of the fundamental units, then those are called as derived units. So example here, if we take length, that is meter, and for mass it is kilogram, and for time it is second, right? So these are the fundamental units. So similarly in derived units, if we take example speed, that is meter per second, acceleration meter per second square, force mass into acceleration, that is kg meter per second square. So these are all the few examples for derived units. Next, so move on to the next topic, that is system of units. We have several system of units, so we will discuss that one, that is system of units. We have old system of units. So in that few old system of units are CGS system, and another one is FPS system, and third one is MKS system. So these are all the few system of units, that is these are the system of units, and these are old. So here we are using SI, that is standard international system of international, that one we call as system of international of the units. We are using the SI units. Next we discuss about what are CGS, FPS and MKS system of units. So first here we write the physical or fundamental quantities. So which are the fundamental quantities? That is length, next mass, and next one is time. So these are the fundamental quantities. So these fundamental quantities are measured in what we are going to measure. These fundamental quantities, the units which we are going to use in CGS system, FPS system and MKS system, right? For these fundamental quantities, fundamental units, right? So fundamental units. So in this fundamental units, we have three systems. So first, in that fundamental units, in case of CGS system, and next FPS system, and next on the last is MKS system, right? So these are the system of units, that is CGS system. CGS system, FPS system and MKS system. So in this system, we are measuring the fundamental quantities, the units which we are going to use to measure these fundamental quantities are, so here C represents what? Centimeter. So centimeter is the unit to measure the length. Hence, in CGS system to measure the length, we are using centimeter, right? So its symbol is Cm, right? In CGS system, the length is measuring, the unit is, the measuring unit of the length is centimeter. So its SI unit is, sorry, not SI unit, it is in CGS system, the symbol is Cm. Next, G represents what? To measure the mass. So in CGS system, mass is measuring by the unit of gram, right? So the symbol is Gm, right? So mass is the fundamental quantity. This mass we can measured by in CGS system is by gram. Similarly, time, S represents what? Second. So time is second and symbol is S, right? So in CGS system, length is measured by using the unit centimeter, mass by using gram and time by second, right? Similarly in FPS system, so CGS system is a French system of units, that is they invented that in the French, right? So that's why this system is called French system. So here MKS is also a French system of unit. So FPS is the British system of unit. So Britishers are using this system in the early stages, right? So that is FPS. So here FP and S represents what? Here the length is measuring in FPS system by foot. So F represents what? Foot. So length is measuring by foot. That is FT. The symbol is FT, right? The symbol is FT. So in FPS system, the length is measured by foot. Similarly, the mass is measured by the unit P represents what? Pound. Pound. So that is P. Right? So mass is measured by the unit pound in FPS system. Similarly, time, here we have S represents what? Second. That is, time is measured in seconds. The unit symbol is S. So this is about the FPS system. That is foot, pound and second. So foot is measured for the length and pound is measured for the mass and S is measuring for the time. Right? So next and the last is MKS system. So here M represents for the length. For the length we are going to measure, M is meter. So symbol is M. Right? So the length is measured by using the unit meter. Similarly, the mass is measuring by the unit kilogram. That is kg. The symbol is kg. Next, time. So here also we have S. That is, S represents seconds. The symbol is S. So these are the old system of units, right? CGS system, FPS system and MKS system. These are all the old system of units. Here the length is measured in CGS system, that is in centimeter, gram and seconds, and in FPS system we measured length in foot, mass in pound and time in second. So in all the three, the time measuring unit is same. Next, in MKS system, the mass is measured by meter and length is measured by meter and mass is measured by the kilogram and the time is measured by seconds. So these are all the three systems which we early used, that is CGS system, FPS system and MKS system. So nowadays we are going to use the system that is standard unit, that is system of international unit, that is SI unit. So in SI unit we have 7 fundamental quantities and 7 fundamental units along with 2 supplementary physical quantities, that is supplementary quantities and supplementary units. So in this system is the SI system. So nowadays we are going to use which system of unit? That is SI system of unit. So SI system means international system of unit or system of international unit, right? System of international units, right? So the long form of SI unit is system of international units, or we can also say that international system of units, right? So this system we are going to use in our physics and also in chemistry, that is SI system. So in SI system we have 7 fundamental quantities. So along with the 2 supplementary quantities, right? So in system of international units, that is in SI units, we have 7 fundamental quantities and 2 supplementary units. So if you look after what are those 7 fundamental quantities means, in that first one we have the length. Fundamental quantities in that first one is length, second one is mass, third one is time, fourth one is electric current, or simply we can say current. Next, fifth one is temperature. Next, sixth one is luminous intensity. Or we can simply say that intensity. Luminous intensity, or we say intensity. And seventh one is amount of substance. Right? So these are the seven fundamental quantities, that is length, mass, time, electric current, temperature, luminous intensity, and amount of substance. So along with these seven, we have two supplementary quantities. That is, in the two, we have first one is plane angle, and second one is solid angle. Right? So those two are the supplementary quantities. So here we have seven fundamental quantities: length, mass, time, electric current, temperature, luminous intensity, and amount of substance. And here we have two supplementary quantities: plane angle and solid angle. So if we have the fundamental quantities means we have also the fundamental units, and here we have supplementary quantities means here for this also we have supplementary units. So if we write the fundamental unit for these fundamental quantities, then for length, here if I separate this one as 7 fundamental. So these are the fundamental quantities, and here for those we will write the fundamental units. So this plus goes to here. Plus two supplementary quantities, and for those supplementary quantities we have supplementary units. So in SI system we are measure the length by meter. The SI unit of the length is meter, and its symbol is m. Right? The length in SI system we are going to measure, the unit is meter, and for mass it is kilogram. The symbol is kg. For time it is second. Symbol is S. Next, electric current, the unit is ampere, and the symbol is capital A. Right? So if we write the unit in terms of words means the letter should be starts with small letter. If we denote it by the symbol means that one will be denoted by the capital, that is A. So this will only valid for the scientist names if we kept for the unit as the physical quantity. That is, if we kept any unit as in the name of the scientist for any physical quantity, then that one will start with the small letter, and for symbol it should be capital letter. For example, for force the unit is Newton. So if we write in terms of words means it should be starts with the small letter. If we denote with the symbol means it should be capital N. Right? So Newton is the SI unit of the force. Then if we write in terms of words means Newton is also a scientist. So Newton name is given as the SI unit for the force. So here we writing the scientist name which starts with the small letter. Here also ampere, scientist name, so starts with small letter, and symbol is represented by capital A. Right? Similarly for joule, energy, that is the unit of energy is joule. So if we write in terms of word means we need to write start with the small letter, and if we denote means it should be in capital letter. So symbol should be in the capital letter, right? So these are the few examples. Next, temperature, that is Kelvin. So Kelvin also starts with small k and denoted by K. Here Kelvin is also a scientist name. So temperature is measured by the unit Kelvin. The unit symbol is K. Next, luminous intensity, that is candela. So denoted by capital C, small d. Right? For the luminous intensity, the unit is candela and symbol we can write CD, that is capital C, small d. Right? The unit for luminous intensity or intensity. Next, amount of substance, that is mole. So symbol is MOL. Right? So these are all the 7 fundamental quantities. For the 7 fundamental quantities, we have the units. For length, it is measured in meter. For mass, it is in kilogram. Time, second. Electric current, ampere. Temperature, Kelvin. Luminous intensity, candela. And the amount of substance is mole. Right? So this one we will study in chemistry, that is amount of substance. So all these are the 7 fundamental quantities. So by using these fundamental quantities we can derive the physical quantities such as speed, acceleration, force, next energy, right? So these are all the derived quantities. Next, we have 2 supplementary quantities. One is plane angle and another one is solid angle. So if you write the unit for the plane angle, it is radian, or in the symbol we can write RAD. The SI unit of the plane angle is radian. So symbol is RAD, and for solid angle the SI unit is steradian. So symbol is SR, right? So these are the 7 fundamental quantities along with 2 supplementary quantities, that is plane angle with solid angle. So these are all the 7 fundamental units: meter, kilogram, second, ampere, Kelvin, candela, mole. These are the 7 fundamental units, and radian and steradian are the 2 fundamental, that is supplementary units, right? So these are the 7 fundamental quantities in SI system, right? So this is about the SI system. Next, practical units for measuring large distances. So to measure the large distances, we have the practical units. That is, if we want to measure the distance from Earth to Moon, then we need the practical method. So by using the practical method, we are going to measure the distance. That is the distance from Sun to Moon and Sun to Earth, Sun to other planets. So those are can't measured by using the measuring instrument. That is either by scale or tape, like those, right? So by using the practical methods, we are finding the units for those large distance. So in that, first one is astronomical unit. So it is denoted by A dot U. So what is astronomical unit? So astronomical unit is the distance between the earth and to the, that is center of earth to the center of the sun. So that distance we call as astronomical unit, right? So the astronomical unit is the distance between the center of earth to the center of sun, right? So that distance we call as astronomical unit. That is the distance between the center of earth to the center of sun. So one astronomical unit is equals to one astronomical unit, that is equals to 1.496 into 10 to the power of, that is into 10 to the power of 11 meter. So one astronomical unit is equals to 1.496 into 10 to the power of 11 meter. That is 1 into 11 zeros. That is 1.496 into 1 into 11 zeros. Right? So this can be approximately, we can write 1.5 into 10 to the power of 11 meter. So this one is we call as the astronomical unit. That is the distance between the center of earth. So if we consider this one as the sun, right? So here somewhere here is the earth. So the distance from the center, from here to here. So this distance we call as astronomical unit. That is one astronomical unit. So this value is how much? That is the earth is at a distance. At what distance it is? 1.5 into 10 to the power of 11 meter. Right? Or we can say 1.5 into 10 to the power of 8 kilometer. Right? So this is about the astronomical unit. So this one we can't measure by using any measuring instrument. So by using the practical method we find this value. That is one astronomical unit is equals to this much. Right? So second one is light year. So denoted by Ly. Right? So in the name itself says that light year. So year and year light. So what it says that light year, the distance covered by the sunlight to reach, that is it travels for 1 year. Then that distance we call as light year. So the distance covered by the light for 1 year, that is how much distance it is covered by traveling in 1 year, then that one we call as light year. That is the distance traveled by the light to cover 1 year. That is the time how much taken is year. That is 1 year. So that one we call as the light year. Right? The distance traveled by the light in 1 year in vacuum. In vacuum in 1 year. So this is the definition of the light year, denoted by the symbol Ly. So light year is the distance traveled by the light in vacuum in 1 year. So we know speed or velocity is equals to, or speed is equals to distance divided by time. That is velocity is the derived quantity which is derived by using two fundamental quantities, distance and time. So here we are going to measure in the larger distances. That is, if we write for the distance here, distance is equals to velocity into time, right? So distance is equals to velocity into time. Here velocity of which particle, that is velocity of the light. So light is travel for the time. Here the given is how much, that is 1 year. The light is traveling for 1 year, then we get the distance, that is how much distance it covered in traveling with the speed of light in 1 year is given as the light year, right? So the velocity of the light, velocity of which one is the velocity of the light. Already we know the velocity of light is, that is we are going to write light year, Ly is equals to, so velocity of light we already know, that is 3 into 10 to the power of 8 meter per second. This is the velocity of light into 1 year. So for 1 year, how many days we have? That is 365 days. Because in SI unit we measure the velocity or speed in meter per second and also the time in seconds. So here the time is in 1 year. Now we need to convert this 1 year in terms of seconds. So 1 year we have 365 days. For 365 days, for each day we have how much hours? That is 24 hours. Next, for every 24 hours we have 60 minutes. For every 60 minutes we have 60 seconds. Then we converted 1 light year into seconds, right? So understand this one. So light year is equals to, that is, this one is the distance. Light year is nothing but the distance traveled by the light, that is light to cover, it travels with the speed of light in 1 year. So 1 year is, we are needing to convert this 1 year for, that is in SI system we don't have the unit in terms of year, that is we have the unit in terms of seconds. That's why we need to convert this 1 year in terms of seconds. Then for 1 year we have 365 days. For 365 days, for every day we have 24 hours. So every hour we have 60 minutes. So every 60 minutes we have 60 seconds. Then this whole 1 year is converted into seconds. So here the unit of velocity is meter per second, and here the time second. So second get cancelled. So this one is in meter. So if we simplify this one, we get the value 1 light year, that is equals to 9.46 into 10 to the power of 15 meter, right? So this one is the light year. So this one is the astronomical unit, and here this one is the light year. So if we simplify, multiply by using the calculus, we get the value 9.46 into 10 to the power of 15 meter, right? So next one, third one is paralytic second. That one is parsec, right? So third practical unit for measuring the last distance is the paralytic second, or we can say that one as parsec. So what it defines means, here we have the arc of length, one astronomical unit, right? So this one is the arc. So this arc length is how much we have, that is 1 astronomical unit. If this arc is subtended by an angle, subtend means from somewhere here we are going to measure this arc length, right? So from here we need to measure means, so if we draw the length for this arc, then this arc subtended by the angle here is the angle. So this arc of length is how much? 1 astronomical unit, right? So this angle is what? Subtend by an angle 1 second. That is 1 to the power of double lines represents seconds, right? So the parsec, that is, we have this value, then we need to find this distance, right? So this represents what? Parsec. So understanding here, the arc of length of 1 astronomical unit subtended by the angle 1 second, then that distance we call as the parsec, right? The distance at which the arc forms or arc of 1 astronomical unit subtended by the angle 1 second, then that distance we call as parsec. So here the distance I have taken is r. That is, r is the distance, that is the parsec, right? The distance at which the arc of length, the distance at which arc of length 1 astronomical unit subtend by the angle 1 second, right? For minute we have 1 zero dash, that is, it represents, sorry, this one is the minute, so this one is the second and here is the minute. Double lines represents the minute and single line represents the second, right? So this is the definition of the paralytic second, that is the distance at which the arc of length 1 astronomical unit subtended by the angle 1 minute. So if we consider this one as theta and this one as 1 astronomical unit, so if we from the trigonometry as we studied, the tan theta is equals to opposite side by adjacent side, then we have 1 minute is equals to 1 astronomical unit divided by r. So r is equals to 1 astronomical unit divided by 1 minute. So we need to find this distance, that is the distance r at which the arc length, this one is the arc. So on 1 astronomical unit is the arc length, right? So for this we know the value of 1 astronomical unit, that is 1.5 into 10 to the power of 11 meter or 1.496 into 10 to the power of 11 meter. Now we need to convert these seconds in terms of radians, then it becomes, for 1 minute we have 60 into pi divided by 180. Right? So now the parsec, that is the value of r, if we simplify this one, then we get the value is 3.08 into 10 to the power of 16 meter. This is the value of 1 parsec. That is, I will write here r as 1 parsec. So 1 parsec is equals to 3 into, that is 3.08 into 10 to the power of 16 meters. So these are the practical units for measuring the long distance. So in that, first one is astronomical unit and second one is light year and here third one is the paralytic second or parsec, right? This one is the right. So these are the few practical units of measuring large distances. So practical units for measuring small distances, right? So practical units, that is first one is 1 micron. So 1 micron can be written as micrometer. So that's value is 10 to the power of minus 6 meter. So the value of micro is 10 to the power of minus 6. So 1 micron is equals to 10 to the power of minus 6 meter. So next is nanometer. So the value of nano is 10 to the power of minus 9 meter. So 1 nanometer is equals to, that is 1 nanometer is equals to 10 to the power of minus 9 meter. Next, third one is 1 picometer, that is equals to 10 to the power of minus 12 meter. So the value of pico is 10 to the power of minus 12. Next, fourth one is 1 angstrom. So 1 angstrom is equals to 10 to the power of minus 10 meter. To measuring the wavelength, we using the word, that is angstrom. So it is denoted by 1 a to the power of 0. So 1 angstrom is denoted by 1 a to the power of 0. That is equals to 10 to the power of minus 10 meter. Next, 1 Fermi. Right? So for 1 Fermi, that is 1, the symbol is 1 Fm, that is equals to 10 to the power of minus 15 meter. Right? So these are all the practical units for measuring a small distances. Because if you observe here, small distances 10 to the power of minus 6, nothing but 1 divided by 1, 2, 3, 4, 5, 6 zeros into meter. If we write in terms of decimals, then it becomes 0 0.1, 2, 3, 4, 5 and 1 meter. Right? So this much small we have. So this one we call as micron. That is 1 micron is 0.0000001 meter. So these are the practical units for measuring the small distances. So next, in the next class we will discuss few units for measuring the masses and also for measuring the time. Okay, thank you.